All right, so the first thing we'll talk about under the quadratic introduction, something you saw in the last section, which was polynomials. Any equation that has the highest exponent of a 2 is a quadratic function. And any equation that is a quadratic function creates a U shape. What do we call that U shape? Parabola. So that's the first word you're going to learn here. Parabola. The shape of a quadratic graph is called a parabola. It's a U shape. Two ways you're going to see it. It could be a U that opens upward, like this, or it could be a U that opens downward, like that. So, for example, this could be the one about diving into a pool. This could be the one about throwing an object into the air. Copy it down. We'll move over in a second. All right, on this next page, these are the three different formats that you're going to see. Hello? You need to copy it? That's fine. So on this page, you see the three different formats that you're going to see quadratic functions in. Let's skip to the middle one. The middle one is called factored form. Why do you think it's called factored form? Because we can see the factors. Factors are the things that are being multiplied. So factors are visible. That's why they call it factored form. What are the two factors? X plus 6 is one of the factors, and the other factor is x minus 3. Now we get to something that you've already learned before. If the factors are visible, that means the zeros can be calculated. Zeros, we use the zero product property, which just means you make them equal to 0, yeah? Yeah. Don't get lost. I saw you on the cell phone right before you're going out, so don't get lost. You don't want me looking for you around the school. I'm fast. All right, so you make each factor equal to 0, and you solve each one. So if you have x plus 6 equals 0, you just have to subtract 6 from both sides. You get x equals negative 6. Let's not do the work for the next one. If you see minus 3, what is it going to end up being? Positive 3. Yeah, I'm going to get there. I want you to focus on what I'm saying one at a time. Now, let's go to the first one. On the first format, this is what you're going to see the most in this class. This format, standard form. Also, you guys have seen standard form a million times here because I taught you how to multiply these two factors before. Whenever you multiply a binomial with a binomial, what's going to come out? A quadratic function in standard form. So you already did this, but now we're going to work with it in standard form. Now, what's important about standard form is being able to label A, B, and C. Focus. Stop copying Vertex Form. We ain't doing Vertex Form. We're on standard here. I want you to pay attention because this is important. Without knowing how to label A, B, and C, you can't do anything in this chapter. Like nothing. So, on standard form, whatever number is touching the x square is A. Whatever number is touching the x is B. And whatever number is the constant, no variable on it, that's C. So here's an example. 3x squared plus 6x minus 7. What is the value of A in this equation? 3, because A is the number that's touching x squared. B is the number that's touching x. What's B there? Positive 6. And C is the constant. Which number has no variable on it? Negative 7. It's old. Write it out later. So anybody not understand how to label A, B, and C in a standard form quadratic equation? You don't know how to? Whatever number is touching the x square is A. Whatever number is touching x is B. And the other number is C. That's it. Now, if the negative 7 was not there, what would be C? If negative 7 was not there, what would be C? 2. Ain't no 2 there. Huh? My question is, if this was not here and the equation was just that, my C is still there, you just can't see it. What's C? 0. 0. If C is not there, then C is 0. You with me? So keep that in mind. Now, trust me, this is like 39 weeks. We've done a lot to get to this point. Okay, look. So now, standard form, we're going to go over to vertex form. I want you to answer this question. Between all three of these formats, which one looks like the hardest one to work with? Vertex form, right? Ax squared plus bx plus c, not bad. Two factors equals 0, not bad. A parentheses x minus h squared plus k. That's more complicated, right? I'm here to tell you that's the easiest one to use. So watch. Let's say you have a U shape like this. The vertex would be that point where that U turns back around, where that U cannot go further down. That would be the point where the U would never go below. So if the U is like this, that spot is that vertex. You with me so far? Now, think about this. They call this factored form because you can see the factors. Why do you think you call this vertex form? Because you can see the vertex. So let me show you with an example here. 2x minus 4 squared plus 10. Watch this. My vertex is h, comma, k. H is the number that's in the parentheses, but there's a minus in the formula, which means that whatever you see here, change the sign. So if you see minus 4 there, what's the real value for h? Positive 4. Now, k is the number that's there. Done. We found the vertex. There's no need to do, no. The vertex has nothing to do with the 2. The vertex only has something to do with h and k. Now, watch this. Let me do. All right, so pay attention here. I just want to show you how you would find the vertex on something that's standard form. You're going to do both in this class, but let me explain it to you. What? Correct, because I just transferred it from this format into standard. So I showed you how to get the vertex from vertex form. No work, done. But here, look how much work is required. To find h, you have to do negative b divided by 2a. So b is negative 16. So negative 16 divided by 2 times 2, because A is 2. Now, positive 16 divided by 4 equals 4. Are you with me? Did I get the same value for H? 4? 4. But in this case, I did it by looking. In this case, I had to work it out. You with me? Now, how do I find K over here? By looking at that number. But here, you can't just look at it because it's not in that format. So what you need to do here is plug in the 4 where X is. So that would be 2 times 4 squared minus 16 times 4 plus 42. If we solve that, let's see what we get. 4 to the second power is 16 times 2 is 32. 32 minus 64 plus 42. 32 minus 64 plus 42 would be positive 10. Did I get the same vertex? Same vertex. But look how much work I have to do when it's in standard form versus vertex form. Yeah, you're going to spend the whole day just finding out the vertex. And you're going to find the whole day just transferring it from standard to vertex, from vertex to standard, a whole day. So this is all going to be in sections. You're not going to have to do all of this at once. This is just a vocabulary introduction. We're going to take the necessary steps, even if it takes us 3 weeks to complete this. Any questions on this one? Move over to the next page. All right. So here we have standard form ax squared plus bx plus c. I just repeated it so that it's embedded, right? Now, the leading coefficient means the first number, which is the number that's touching the x squared, right here. So this is the second vocabulary term you're going to learn here. These are going to be the words in the vocabulary, upward and downward. So if the A, leading coefficient, is positive, then it opens upward. So the U would open up like this. And similarly, if A is negative, it's going to open downward. So the U would open to the bottom. So that's one way A affects the graph. A affects the graph by flipping it upside down if A is negative. Now, this is the second part where A affects the graph. If A increases, so the bigger value to A, the more narrow the graph gets. So if A was 1, the graph will be like this. If A is 100, the graph will be almost perfectly straight, very narrow. Exactly. Now, if A decreases, for example, it's 1, and then you decrease it down to 0.2, that graph is going to be wider like this. So narrow, wide. Bigger the number, narrow. Smaller the number, wider. Now, I'm going to show you these 4 things right now on Desmos once you finish copying. Let's go to Desmos now so I can show these 4 things in action. So we'll start off with 2x squared. Look at that red U shape. Steph, look at this. Forget the notes. See this red U shape, right? It's 2x squared. That's the graph for 2x squared. Now watch. What if I turn the 2x squared into 22x squared? What happened to the graph? It gets more narrow. Now what happens if I turn that 22 into a 0.05 instead? I made it smaller. What happened to my graph? It gets really wide. That's the first thing you got to see. The next thing is the negative a value. So if you have positive 2x squared, the graph opens up. But if I put a negative on that too, what happens to the graph? It opens down now. So those are the four things that change. The skinnier, yeah. Why? Think about this, right? If the numbers are big, that means they have to get big quick, right? How do you get big quick? By making it very narrow, very tall. Because you can get, how can you get to 100 quicker? By being narrow or being wide? Being narrow. So that's the hint. That's why it works out that way. Any questions on the graphs and the value of A and how it affects it? All right, let's go to the next page. Now, this is super important. Please pay attention. Intervals. Intervals always deal with x values. Always. So whenever you see the word interval, all you're going to do is this. I like to show it with this. All right. So pay attention to this. If I say, what's happening to the graph between interval -1 and +2? I'm going to look at the x values between what? -1 and +2. So between -1 and +2, is that blue line going down or up? What you're looking at, the blue graph, I'm going to block off everything except from -1 to +2. Is that going up or down? From left to right? It's going down. So that means between -1 and 2, it's decreasing. So between -1 and +2, that is decreasing. Now, what's happening between +2 and +5? What's happening between +2 and +5? Let's see. +2, +5. Is that going up from left to right or down? Up. It's going up from left to right. So that would be increasing. So here I'm going to mark it now. Between 2 and -1, this piece of line is going down. That's why we call it decreasing. Now let me use a different color. Now between 2 and +5, what's happening to this graph? Is it going up from left to right or down? Up. That's how we call it increasing. Are you with me? I'm not sure you're with me, so let's see. All right, don't look at that blue line. Look at this. Who cares? Who cares? I just want to make sure you know how to read intervals. I know it's not a you, but I want to make sure you learn how to read intervals, right? So what's happening between -1 and +1? What's happening between -1 and +1 on that red line? Let's check. -1, +1. From here to here, what's going on with that line? Yeah, up or down? Increasing. Right? Because it's going up. You with me? What happens between 2 and 4? Nope. What? It's going what? It's going straight. What does that mean in terms of increasing or decreasing? You're right there. It stays the same. That means it's not increasing and it's not decreasing. It's staying the same, constant. Something can be increasing and decreasing, right? Same thing with constant. Something can be going up, but not going up. It has to be one of those three words: going up, going down, or not going anywhere. You with me? So what I want you to do is just learn how to read intervals, x values, and what's happening to the graph. Any questions on intervals? We'll get some more practice on it, so don't worry. So now we get to the parts of the graph. So the first part of the graph, as you can see, there's a bunch of things labeled here, but I circled y-intercept because that's what I'm going to talk about on this page, the y-intercept. Now, the y-intercept is just the point in which the parabola meets the y-axis. So we're just looking for where this U shape touches your y-axis. Where does it touch? Right there. What? Yeah, third 9 weeks. And all I'm saying is y-intercept. I get you, but look, y-intercept is where the U touches the y-axis. That's it. That's it. Slow and steady. Y-intercept is where it touches the y-axis. Now, pay attention here. That y-intercept, what are the coordinates to that y-intercept? 0, comma, -3, right? This point right here is 0 and 3 down. So 0, comma, -3. Now, why do I show that? Couple reasons. Look at this example I have here. How can I find the y-intercept here if I don't have this graph? By plugging in a 0 for x. Let's do that here, see what we get. 3 times 0 squared plus 6 times 0 minus 2. What's 0 to the second power? 0 times 3, 0. What's 6 times 0? 0. What's left? -2. So that tells you the constant is always your y-intercept. So no matter what number it is, whatever number is not touching a variable is your y-intercept. Always, just like on a linear equation. On a linear equation, when you have y equals 3x minus 6, what's the y-intercept there? -6. Same thing as quadratic. The y-intercept is always the constant. Now the next part, this part is going to be like 2 pages because it involves two things that combine to give you the vertex. So, don't worry about it. Like I said, this is the overall introduction. You're not doing all of this in one day. All right, so look, this vertex, we all know, is the lowest or highest point of the U. In this case, it's the lowest point, so that would be your minimum. If the U was like this would be the point, and that would be your maximum, right? But because this is a minimum, I'm going to explain to you what makes up the vertex. The vertex is H, comma, K. H is this orange line that you're looking at here, axis of symmetry. And what does H do? It divides the U into two perfectly equal parts. So it cuts the U in half. But notice how the line is dotted. So it's not a real line, it's an imaginary line. So that's why in the definition I put axis of symmetry is an imaginary vertical line that divides the parabola into two equal parts. Now, because that's a line and every line has an equation to it, you have to remember how an equation of a vertical line looks. A vertical line equation is x equals a number with no y anywhere. So whatever you get for h, put x equals next to it, and that's your equation. So notice on the previous example where we had 4, 10 as my vertex. 4 would be h, and 10 would be k. So whatever number's here is your h, whatever number's here is your k. The imaginary line. But you're going to use this mostly in word problems. So for example, h represents an x value, right? The x value where the vertex is. That's what h represents, right? But the h value where the vertex is also has a y value. That y value is k. And k is your minimum or maximum, the highest or lowest y value achieved by a parabola. Yeah, that k, that number will be your answer for minimum or maximum every time. You had a question back there? No? All right. All right, so pay attention here. Now, look at the parabola that I have here. Let's see who can come up with the answer. What is the minimum or maximum from this graph? And read the definition before you answer. Highest or lowest y value achieved by the parabola. So what's the lowest possible y value that you reached? -4 is correct. The vertex is right here. What number is this on the y-axis? -1, -2, -3, -4. You with me? So that means that -4 is my k value, my lowest value. You with me? Now, my axis of symmetry is touching what value on x? 1. So my vertex here, 1, -4. 1, -4. That's my vertex. You with me? We're going to do like 3 pages of this same vocabulary terminology. That's H. H is your axis of symmetry. K is your minimum or maximum. That's fine. Just make sure you understand. All right, next page. So this deals with the vertex again. Vertex is H and K. H is the axis of symmetry. K is your minimum or maximum. I put depending on the parabola because if the parabola opens up, this would be a minimum because it can't go lower than that. If the parabola opens down, then this would be a maximum because it can never go back up. Now, this is the work that we did on one of those pages. To find H in standard form, you just do -b divided by 2a. So we'll do an example at the end on the same page. Let's just read. So once you find out what H is by doing -b over 2a, then you have to find K by plugging in H for X in the equation. So -x squared minus 6x plus 16. This is the example I'm going to use to show you how to find the vertex. So I know we already did it one time, but we're going to do one more example here. So first thing we have to do is find h. To find h, to a, exactly. So negative b over 2 times a. Don't forget, if b is negative, it's going to be minus minus, so make sure you change the sign. So minus minus 6 becomes positive 6, divided by negative 2 is negative 3. Now you just have to plug that in for x so we can find out what our minimum or maximum is. In this case, I know it's going to be a maximum because the first number is negative, so it's going to open down. So it's going to be a maximum. If I tell you the u is like this, will it ever go past this spot? Will it ever go higher than that? That's why we call it a maximum, because it can't go higher. If it's a u like this, will it ever go lower than that? No, so that's your minimum. Now that we got h, which is negative 3, you plug that in for x in the equation. So that would be negative 1 times negative 3 squared minus 6 times negative 3 plus 16. Exponent first. So negative 3 to the second power is 9. 9 times negative 1 is negative 9. So we have negative 9 plus 18 plus 16. Negative 9 plus 18 is positive 9. And 9 plus 16 is 25. What is the highest point of this graph? What is the highest point of this example we just did? 25. Of course. It says it there. That number is your maximum or minimum. You understand? Either way, remember, we're going to do each section from here in a full day's time. So you're going to get practice on this 2 days straight without touching anything else from quadratics. So you're going to get good at this once you practice, obviously, on 2 full worksheets or a worksheet in the IXL. All right, this is great here. Leaping frog. So this is an example of a word problem for quadratics that'll ask you for vertexy questions, right? Vertexy. We gotta make up words. So let's look at question A. After how many seconds did the frog reach its highest point? Do you think they're asking for H or K there? On A. After how many seconds did the frog reach the highest point? Are they asking for H or K? Why? My question either way was going to be why. So you said H. Why do you think it's H? Even if you're wrong, tell me why you think it's H. I'll stop you right there. It is. So pay attention. H deals with x values because H is the x value, right? What does x values always deal with in word problems? Time. What does seconds represent in life? Time, right? So whenever they're asking for time of the highest point, it's H. If they're asking for the highest point the frog reached, that's your K. You with me? You get the difference between the two? That's like saying the frog reached 100 feet in the air. But after how many seconds did he reach that point? That's H. Yeah, but in word problems, H would never be negative because seconds will never be negative. Have you ever done anything for negative 5 seconds? Right? I taught the lesson. It only took me negative 35 minutes. You know, like negative time can't happen. So that's why, that's a little hint. In word problems, h will always be positive. If you get a negative h value on a word problem, you did something wrong with a negative b divided by 2a. So pay attention here so we can get on with it. After how many seconds? That tells me I got to find h. How do I find h? Negative b divided by 2a. So in this case, a is negative 1. B is positive 3. And C is positive 10. Now let's plug it in and solve. Negative B over 2 times A. That gives me positive 1.5. So if they ask you for the axis of symmetry, then that is the answer, but in an equation format. X equals 1.5. That's H. Now, how do you find K? Once you have H, plug it in for X. So now we're going to plug it in into the equation. Negative 1 times 1.5 squared plus 3 times 1.5 plus 10. Exponent first. So 1.5 to the second power is 2.25 times negative 1 is negative 2.25. 3 times 1.5 is 4.5. Bring down your plus 10. Now you put all that together and you get 12.25. So here's my question. If the vertex is 1.5, comma, 12.25, after how many seconds did the frog reach its highest point? After 1.5 seconds. What was the highest point? 12.25. Here's the real question, because word problems deal with common sense. Is that feet or inches? Is that feet or inches? I know I didn't say it was feet or inches here, but you have a brain that works and you have common sense. Why inches? The answer is correct. Why inches? Because a frog can't jump 12 feet. Of course it's got to be inches, right? How about if it was a frog that was the size of your fingernail? Instead of inches, that'll probably be something smaller, centimeters, millimeters. You with me? So it depends on the animal. Can you jump 12 feet in the air? Then the word problem would have said jump off a building. You get me? Which you will get word problems like that where it says if a dolphin jumps in the air and a bird jumps off of a building, at what point are they at the same place? So you're going to get questions like that. We're going to work on it later on once we work on word problems here. All right, next page. All right. This is the most important section of quadratics. All these 4 words right here mean the same thing. X-intercepts, roots, solutions, zeros. All 4 of those mean the same thing. It just means where that U touches your x-axis. Where the U touches your x-axis. Negative, yeah, like negative 1 and positive 3. That's where it touches. Focus, you haven't wrote anything. So that's why I put the definition here. All of these words mean where the parabola meets the x-axis. If it's a word problem, what's your x-axis? The ground, the floor. Any question on where it's located on the graph? What? No, I said any questions on the placement of it on a graph? Like where are you touches the x-axis? Y-intercept. It's touch. Why is it called the y-intercept? Because it's touching the y-axis. Now, there's different ways to find these solutions, right? We're going to do each one of these on different days so you practice different methods of solving for the same thing. So, factoring you already did here before. This part, you did the zero product property before. So one way to get these solutions is to factor and use the zero product property. Now, two things can happen, right? The first thing that can happen, you can get to this test at the end of the year and realize, I forgot factoring. Now what do, right? Don't worry, there's another method, quadratic formula. What else? What if you're trying to factor it and the equation is not factorable? You just can't factor it. How do you get the solutions? It's not now you can't get solutions. There's a different method for it. So quadratic formula works every time. For solutions, quadratic formula works with any quadratic equation you could think of because it's all calculator work. So no matter how large the numbers are, you got the calculator, it does it for you. And then the third method is to complete the square. Honestly, my least favorite method, but I do like to teach it. And you do need to know it. So those three are the ones we're going to learn, the methods we're going to learn to find these solutions. Okay? And don't forget, if this was a word problem, these solutions represent seconds, right? So if your two answers were -1 second and +3 seconds, which one's a real answer? Only the 3. This would not be a real answer if it's a word problem. You with me? So on word problems, it always has to be a positive value because x-axis always represents time, usually seconds. So for this one, you're going to learn the song. We'll get there. Song's not today. What? If I get done with the lesson in time, you can start the activity, but most likely it's going to be tomorrow you're going to do the activity. But the activity is the index card activity, the vocabulary activity. All right, let's move on to the next page. So, frog leap equation. So that's the same equation that I used for the other one, right? But instead of asking you for the highest point or how many seconds until you reach the highest point, I'm asking you for solutions, roots, intercepts. So, what I'm about to do, I don't want you to copy. Listen carefully. I want you to put your pencils down for what I'm about to do because we're going to learn this and do it another day. But I want to show you what you're looking forward to. Okay? So, I'm going to show you factoring first. Pretend you've learned this already, right? These are the steps you're going to take when you learn how to factor this. First step when you factor is find the greatest common factor between these and factor it out. If it's a 1 here, there's nothing to factor out. But if it's a -1, you have to factor out the -1. So if I took away the negative from here, what's left there? X squared. Positive 3x divided by -1, -3x. Positive 10 divided by -1, -10. Now, if I factor this, I'll teach you later how to factor it, but if I factor it, my two factors will be x minus 5, x plus 2. And there's a negative 1 on the outside. So far, so good? Right? I'm going to show you how to do this later. But you did already learn how to distribute this and come up with the trinomial on top. Now that we have this, we use a zero product property. X minus 5 equals 0, and x plus 2 equals 0. I solve both. Plus 5 on both sides. That gives me a positive 5x value. Question? Oh, and there's going to be negative 2. Very good. X equals negative 2, right? Those are my solutions. If we were talking about a graph, they would touch where? On those numbers. Negative 2, positive 5. You with me? Now, I'm going to show you the same way, well, same answers you can get using the quadratic formula. So, the quadratic formula is the song that I'm going to teach you, so you'll all memorize it. Head up in the back. Woo-hoo! Woo-hoo! My man, I can't let you sleep here, sir. All right, excuse me, guys. Let's continue. So, here I'm going to show you how to do it with the formula. Steph, pay attention. You don't have to write this down. Just watch me. So, the song is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So, you're going to learn that song. You will learn that song. And now I'm going to show you how to work with it. What did I do? Okay. All right, so pay attention. Over here, what's A? Negative 1. What's B? 3. What's C? 10. Those are the numbers we're going to plug in here and solve. So, negative B plus or minus square root of B squared minus 4 times A times C all over 2A. I just replaced all the A's, B's, and C's. Now, wait. Do what's in the square root first. So, 3 to the second power is 9. Negative 4 times negative 1 is positive 4. Times 10 is positive 40. What's 9 plus 40? 49. So, our answer is going to be coming from negative 3 plus or minus square root of 49 divided by negative 2. Now, what's the square root of 49? 7. So my two answers are going to come with these two signs. Negative 3 plus 7 divided by negative 2. And the other answer is going to come with the opposite of plus. Negative 3 minus 7 divided by negative 2. What's positive 4 divided by negative 2? Negative 2. Is that one of the answers we got? Yes, it is. Negative 3 minus 7 is negative 10. Negative 10 divided by negative 2? Is that the answer we got? Same answers. So if you know how to factor, you can factor and use a zero product property. But if you learn the quadratic formula, the factoring, you use very little because this always gives you the solution. Whether the equation is factorable or not factorable, this always works. That's why this is like your safety blanket. You can literally show up to the EOC at the end of the year, forget everything about quadratics, but you remember the quadratic formula, and that'll give you a big percentage right on that. That's your safety blanket. Okay? Now, this is the yellow question here. If these two were the actual real solutions, which one is a real life solution for this scenario? Only the positive number. 5. Any questions so far? And that's the end of the vocabulary lesson. Any questions? How much time we got left? We got 25 minutes. So what I'm going to do is I'm going to let you get ahead on the IXL for this week. The vocabulary one for this. Let me find out what it is, what the number is.